Hi, this is my last video in a series on files in Java, and this one is not about files really. This one is all about how to do exception handling and how to try to do that somewhat gracefully. So first off, I started with this project called Graphical Department with Persistence, which is on my GitHub webpage where I have this username here. And it's under the repository called Java Examples Basic. So what I just did, I just downloaded, if you click Java Examples Basic, I just downloaded this as a zip file. So you need the one called Graphical Department with Persistence if you want to follow along. Otherwise, you can just watch and see what I do. So this is a small project that I made at some point in time to try to demonstrate different kinds of files like binary files and object serialization using lambdas and streams and java.nio and normal java.io and comma separated files, all these kinds of things. And I did a very simple project, which I think came out pretty well. So it has a graphical user interface, which I also like because it makes it easier to see, and it suits the topic here perfectly, because oftentimes we have graphical user interfaces that are for the user. So when we do graceful exception handling, it's often to help the user. So let's try to look at the project, what it looks like when we open it up. So this is originally made in NetBeans. I open it up in IntelliJ, and what I did then is I just removed the NB project folder completely. So I didn't need that one, and the rest I just kept here. And I just right click and choose run on the graphical department. And of course, I need to import the JavaFX library. You can see how I did that by watching my video on that. This video is to show how we can handle things like errors and stuff like that. So let's try to run the program first. I'll show you what the program is all about. So basically you have some program here, and what you can do is you can load. It will automatically load from the kind of files. So we have like 4 kinds of files, and they are situated here: department stat, department neotext, department cert, department text stat. And no matter which one let's take this one for example, this loads in 2 persons. I can say, for example, ID number 3. I'll go like this, and 4. Oh, Rick. Like that. So I can add multiple persons. I can save that to the text file, and I can go to some other file, load it in, go back to the text file and load that one. Then it loads the data here. And if we go into the text file, we can see that it's a comma separated file. So that's how it reads and writes that. And I show you in previous videos how to do all of these kinds of files here. So that shouldn't be any problem. Okay, so next thing is I have this program. For some reason I have a lot of errors right now. I don't know why it does that. It should have access to department. I should have imported that. Sometimes when you import NetBeans projects, it does like this. Yes, so it cannot find anything. Okay, so the only thing left to do is to close the project and terminate that, and then reopen it, and then it always works, almost always. Okay, it didn't really. Yeah, so let's see what's going on. So it says import graphical department with persistence. Try to see. It should. Says there's an error here. there's an error in source. Let me just try to fix that. So now it's magically working, and the thing I did was to close IntelliJ completely and reopen it. So now I can actually see the program running again. That was kind of weird. It does that sometimes when you import it like that. Okay, so let's go back to looking at these errors. So things can go wrong when you try to load things or save things. We can get different kinds of exceptions, and how do you handle that? So let's just look at the code first. So if we go into the code, we can see I put it into different folders or different kinds of packages here. So I put it into something called B for business entity, and here I put the raw data here. I also put business logic layer, I have a data access layer, and so forth. So I have different layers in my system, and let's just try to draw them. So first off, I do have the top layer is what I call the GUI, and this is where all the user stuff resides. So in my GUI, I use the MVC model, like I use the model, and I have a view, which is the fxml file, and I have a controller. And what I do is the view, I get some clicks and stuff that will work on the controller. The controller updates the model, and the model updates the view, which is actually done automatically. So then I have another layer, the business logic layer below that, and inside the business logic layer, you should see on your left here that I have what I call a department manager. So I have only one class, department manager. I'm just shortening it, so hard to write like this. And then this department manager, under this I have a data access layer, which is a bit more complex than the others. I'll show you later. But that is used for actually saving it into the files, and I have different kinds of files and stuff like that. But then I also have something called business entities over here. And the idea with this is, of course, to let everyone work with these kinds of files, or POJOs, or whatever you want to call this. And this one, I only have one, and that is the department. I'll try to write it. Yeah, you get the idea. So I have the department here, and this is what you see over here. So the way it works is that everyone knows about the business entity. So everyone knows about department. Everyone here knows about that. So that's no secret. The department only holds data, so it doesn't have any functionality really, other than holding the data. And then the model here talks to the department manager, and the department manager talks to the data access layer. And no one talks the other way, so the data access layer doesn't know anything about the business logic layer. The business logic layer doesn't know anything about the GUI layer, but it does get something back. Maybe we are asking for a file, then it sends the file back in some kind of like a list or something like that. So we can get, we can call methods downwards, but we can only get answers as return values upwards. So why am I showing this? I'm showing this because what's interesting here when we talk about exceptions is that we can have exceptions in many places. We could basically have an exception over here. We could have an exception in the data access layer. For example, with reading and writing files, we could have exceptions in the logic layer. Could be something like divide by 0 or something like that, trying to do calculations. Or we can have exceptions in the graphical user interface, like something like thread violations, or we could have something like a null pointer or something like that. So a lot of different kinds of exceptions can occur in different places. What's very important to understand is that what we want to do is we want to give the user's up here, it's a red user, the user's up here and working with the graphical user interface. So the user actually only sees what's on the view here. So if we have an exception down here in the lower layers down here, it would be a very, very bad idea to kind of just print this to a console or something, because the user wouldn't see that. But there can be situations, for example, let's say that this data access layer is trying to gain access to a file. So let's say the file is out here and it asks for a handle for this file, trying to read it. And this file I forgot about, I already opened the file in another program, so it gets an error. Let's say it gets like this, and we get an exception down here. Sometimes maybe we would just want to try that again. So we could actually try multiple times without actually the user knowing about the exceptions. So this would be kind of a graceful way, and maybe now I can access it, or if it's on a network drive, network connection might be re-established. It's if it disconnects to a web page, it might want to try more than once. Maybe if it's busy right now, or wait a little bit longer. Could be a database that we're connecting to, could be a lot of different things that we are connecting to from the data. This is a cloud. So we can connect to lots of different things like that. So we should try to handle it in a way that's best for the user. If it's best for the user just to try again, then we'll do that, but we might need to let the user know about that. There can also be situations, for example, if there should be a file here and it's not really here, so we get a file not found exception, and that's a big problem and something the user has to take care of, and we can't handle it, then we should give that message back to the user. But the problem is that the only thing we can actually work with from the data access layer is the console. But we don't want the message on the console because the user doesn't interact with that. So we need to have some way of letting the user know. And this is what we do with exceptions. So we kind of need to send exceptions back here, and that is also okay. And we need to think about which layer should we handle this on. So we could handle it on either of the layers, but we need to know how to handle it and how to get the message to the user without breaking this structure here. So we cannot do something like calling a method on the department manager saying, give user a message or something, because that would break our architecture. So we're following this 3-layered architecture to make sure that this doesn't happen. Yeah, so let's try it out. So in here, what you can see is I have my data access layer is built into different things. We have what is called a department persistence manager. And this department persistence manager has a file handler, which is of type abstract file. I'll come back to this, and a file name. So what I did, I created kind of an interface to all files so that all files look the same no matter which kind of file they are. And the only thing they save is the file name. This is the same. And I have methods. You see I used a file handler, which is abstract file, and then I have a method for adding a department, get all, get by ID, delete by ID. And this abstract file is somewhat like an interface, but because I have some implementation, I kept it as an abstract class instead. So we see all of these abstract methods are the ones that needs to be used by the different types here. So for example, the one we used before with the text file, this is the code for actually reading and writing comma-separated text files. So yeah. So what can we do with this? So what we can see here is that there's a lot of stuff going on here. And actually all of them throws exceptions. So let's say now we're the user, we want to add a department. So let's run the program. That'll show what's happening. Maybe even let's try to, I'll put a breakpoint and I'll use the debugger. So I'm putting text file that's loaded. So I want to add a department, so I'm adding department 5, calling it something, Esberg. I click add, and probably wasn't was that the right file? Maybe not. Oh, it should be that one. Okay. So it should go into this method here and try to add that person to the file. I don't know what happened there. But when it comes down here, it goes into this buffered writer, and then it asks to append that to the file, the ID and the name, and it puts it at the in the file, and then it also writes a new line to that file. So what can go wrong here? So we see we actually put a try block here, and that is only actually not for try catch, but here I use the try block only for automatically closing the buffered writer and file writer. So the exception itself, I'm throwing that as an exception from the method, meaning anyone using the add department method needs to throw this. I do this because I'm thinking this is a file operation. So what I'm really doing, I'm trying to add a department to a file. If that fails, something is wrong with the file. So what I do then, I throw this exception upwards to whoever is calling that, and that can be the department persistence manager. And if you look at the department persistence manager, it's just as lazy as the other one. This also throws it upwards in the system. So let's look at the department manager in the logic layer. And let's see. So here we actually see I try to catch it. So if we go to add department, did I put that here? Here it is, add department. Okay, I'm probably the reason before it uses this at all. So it isn't using this, but yeah, if it was using it, it would then actually it would try to add a department in the department manager in the other layer. And what would happen then is I would get an IO exception, and that IO exception is catched here. And what I do then is I give it quite a bad a message here, but I'm creating something called a department exception. And department exception, I put that as something here as a utility class, which is somewhat, when we look at it, somewhat like the business entity. It's something they should all know about. So it's kind of, I created my own kind of exception for my program. And these kinds of exceptions, the idea with that is actually to throw these messages upwards in the system. So the reason for creating a department exception is to make the graphical user interface, let's find that, so that the graphical user interface here, or the department model here, is only dependent on department exception and not IO exception. And the reason for that is because IO exception comes from the file. So let's see here, go here, for example, look at the imports. We can see that IO exception is from java.io, and this is only used for files. So if we were to change this new IO text file thing, if I change this to working with databases or working with web or something like that, I would be dependent on the IO exception here, which would be a bad thing. So right now, the model here is not dependent at all on anything that has to do with files specifically. So that is really cool. That means that our graphical user interface up here is totally independent of the rest, and it's totally unaware of which kind of saving we're doing. Are we doing cloud saving, or are we doing database saving or file saving? It doesn't really care. It just wants to save the data somehow. So this is why I did it like that. So we can improve on this. So what happens then if we get a department exception? So we see that the department model throws a department exception, and that throws that to the main controller, which uses the model. So for example, let's go here and let's see. When we click load, I say load departments. And what does it do with it? It shows and logs the error. So what does that mean? It actually means I have this logger class where I log the error, and I log it as severe because this is really bad. And then I actually display an alert message saying, get the message, which was, if we go back to our business logic layer, it will say cannot add department. Really not the best message. Let's go back to our department model, or sorry, main controller, and we can see it will write that to the user, and then it would create like a new line, and then it would see error log for technical details. So this is one way to do it, and I think it's not the best way. So I'm going to talk about what I want to improve on this. So let's try to look back at the business logic layer. So we see in the business logic layer, we throw the department exception. But the reason why we throw the department exception here is, and we say cannot add department, is because the department here the department manager doesn't really know what's going on. So when we get an IO exception, the department manager actually becomes reliant on files. So we should, in my opinion, we should actually move this department manager down another level, because I don't want the department manager to be dependent on IO exceptions. So I think we should go down to the layer below, the department persistence manager, and instead of throwing IO exception, we should throw the department exception instead. So we would do like this: department exception, department exception. So let's try to refactor. And what we would do then, we would need to handle these exceptions that we get. We need to handle that everywhere. So surround with try catch, surround with try catch, and I'll use the time machine. And that was the last one. Nice with this time machine. So now it says print stack trace with all of them. So what I want to do is, this actually knows I'm trying to add the department. So I should add the message here instead. So I think I'm going to go up to my department manager, and this says throws department exception. So maybe let's just take the catch part here and remove that. You see? And I'll remove it here. I'll remove it here. Maybe I should use the time machine. I think I will. And this was the last one, like that. So, oh, almost not completely done with this. Thought I was. Damn you, time machine. So that's it. So now they all throw department exceptions, and now we can remove the java.io exception here. So now this class is no longer dependent on which type it is below this. So it doesn't know anything about the type. So now we have problems down here. So let's see. No problems to see here. Try to see what the error is. Missing return statement. Okay. But there is no. Okay. Yeah, so in this case, if we get by ID, we want to return null if we cannot find it. And the other mission is the same, return null. Okay. So now we move that down a notch. So now we're printing a stack trace, but we really want to throw a new department exception. So what we're going to do is going to do something, wow, sorry. Going to do something like this. I don't know what I'm doing here. Yeah, so we want to send back a message or something using our department exception instead. And we already throwing that here. So in this place here, add department, let's do a new. So catch will say throw new department exception. And then we're going to put a message here that will say something like problems writing the file while adding department. Okay. And I think we can put the original IO exception here so that it won't be lost. So we can do that for any of them. So the good thing about unreachable now, okay. So the good thing about this is that the department persistence manager knows that this is a problems reading. The file, yeah, with departments. So the good thing is that it actually knows what it's doing here. Then we go to the next one. And again, we don't need this. So it says problems reading the file with ID, and then we can do something like put department ID here just to make it a bit more. And then this one, problems deleting from the file with departments. And then this one, problems clearing the file with departments. And the last one, problems adding departments to the file, like that. So now we're putting it into human words. The reason why we're not creating these human descriptions in the GUI is because the GUI doesn't know that much about it. If we wanted a more specific problem, we could probably also look at different kinds of exceptions. For example, if we would go down further one layer in the data access, even further down the data access layer, and go into, for example, in here we could use the exceptions then we would be able to say things like file, if we couldn't find the file, or we could do even more specific problems here. But it's important to do it in the class that knows most about it. I think it's very nice to have them all in here. If we pushed it down further, we would need to implement it for each and every one of these classes here. So it's nice to have it here, and we do have some information about the problem that occurs. So one of the things I could try to do, I could take the, let's see, open up the new text file, and let's just rename that for a second. Rename, blah, blah, blah. Can I do that? Refactor, rename, new text, era, I'll put that here. Not search for anything, refactor. So now I renamed that. I'll try to run the program and try to read that file, which is not there. So I'll go to new text and I'll click load. And what I see, I get the error log out here. So that is the actual logger. So I actually get a nice error here for programmers to actually dive into and see what's going on. So we can go here and we can see this is where it went wrong. And here we can see this is problem reading file with departments. So, and I even get this nice error message for the user that says problems reading the file with departments. See error log for technical details. And this error logger, we could also make it not printed here, but do the put it into the Windows event log, or put it into a log file, or whatever, where we want to save that. We could send it over like Microsoft does, or many others send it over the internet to our company or something like that. So we could do anything here. So the entire idea is just not to strangle these exceptions and try to make them available to the user in a meaningful way. And sometimes that is showing the error to the user, and sometimes it is just trying again, or even in some rare cases, we just want to ignore exceptions. In general, we'll try to program around exceptions because we don't want exceptions to happen. So oftentimes exceptions should be exceptions. It should be an exception, something that should occur, but we can't always make sure that it doesn't occur. So this way we can try to make it just a bit better. So I think that was basically it, what I wanted to say with these exceptions here. You can also get by without creating your own exception. You can just reframe it as a normal exception. You should also know that there are multiple types of exceptions. Mainly there is what is called checked and unchecked exceptions. So checked exceptions, some of the exceptions are like the java.io exception. This is something you have to handle. So you cannot run the program without catching an IO exception. But there are others like division by zero exceptions or null pointer exceptions, which you cannot foresee and you don't need to say how to handle. For example, null pointer exception would be horrible if you had to handle that for every piece of code that you would write. So you would have to do it anywhere. But some exceptions are nice. We know when we're dealing with I/O, this is often a place where exceptions can occur. Last thing before I end this, I just want to say that remember, if you take anything from this, remember that the user doesn't see this at all. This is something for you to see as a programmer, and the user doesn't care about this at all. They are not able to read it. Maybe you aren't even able to read it properly. So this is not a good way to make the user aware of a problem. And you probably tried playing a game or something and getting something like it just says null pointer exception. or index out of bounds exception, something like that, and then it just closes the program, and you sit back as a user and have a very bad experience with that. So you should at least give the user some idea what's going on. In this case, for example, let's say that I was the user and I was working with this program, and I go in here and I say, now I want to load this, and I get the problems reading the file with departments. So because I'm a somewhat experienced user, I know, oh, it's a problem reading the file. If I just got an error saying there's problems, or I got something like this, I would have no idea where to look. But as a user, I know what a file is and I know it's saving it here. So I might go in, maybe not, of course, not through IntelliJ. I would go in here and I would see, oh, there's some problem here with the name of the file. It says I better fix that naming here. And as a user, I'll actually be able to fix my problems myself. So the more you can help the users fix their own problems, the better for everyone. Okay, that's it for exceptions. You can look more into exceptions in Java just by searching for Java exceptions. And you'll find all of these images here. If you just do something, you can see there's so many kinds of exceptions. There's the normal exception. There are different kinds of errors like stack overflow, out of memory, runtime exception, IO exception. You see here, this was the one, file not found or socket exception, index out of bounds, illegal argument, array index out of bounds, so forth. So many kinds of exceptions you can look at. And I won't go through all of them in this video. This is something for you to find. This video is more about just understanding the importance of showing a good message to the user and not just writing something like e.print stack trace or something like that. Okay, thank you for watching. This was the last video so far in my series on files in Java. Bye.